Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien, and welcome to Destination Tomorrow.
This program will uncover how past, present, and future research is creating today's knowledge to answer the questions and solve the challenges of tomorrow.
We begin with an issue that affects all aircraft that fly in our atmosphere. The formation of ice on airplanes is not only an issue on the runway during cold weather, but can form on airplanes in flight. This problem can be a dangerous situation for any piloted aircraft. Fortunately, NASA has been conducting research on icing with a unique wind tunnel facility that creates icing conditions on aircraft.
Jennifer Pulley takes Destination Tomorrow behind the scenes to see how this icing research tunnel is helping engineers combat icing conditions on aircraft.
Thanks for the ice. You know, there's nothing like a beverage chilled with ice during a long flight. Inside an airplane, ice is something passengers desire. However, outside an airplane, ice can be dangerous, especially if it forms on the wings or engines. I had the opportunity to speak with Judy Foss Van Zanti at the NASA Glenn Research Center in Cleveland, Ohio. She's researching the effects of icing on aircraft at a unique facility called the Icing Research Tunnel. Researchers at this facility study the formation of ice on the exterior of aircraft. So while flying, the only ice you'll need to worry about is the ice inside your cup.
Well, I'm standing right here in the Icing Research Tunnel. Right here we create on Earth what it's like for an airplane to fly through an icing cloud up there. To do that, we got to make it windy, cold, and wet. Now right now I'm standing in front of the fan. We have the fan to create the wind, and in the test section, which is a much smaller cross-sectional area, we can get winds up to 400 miles per hour. So that's about as fast as a plane might fly through in an icy environment. We create the cold with our heat exchanger, 1,700 ton. It can cool 500 homes. That's how big it is. We can get from 0 Celsius down to about -20, which is where the icing might occur in nature. And we have spray bars. The spray bars is what makes the icing tunnel. We create the rain. We create a mist that the airplane would fly through. Now the thing about the spray bars is the researchers need to control both how much water is in the cloud, the liquid water content we call it, and how big the drop size is. And we have spray bars specially designed to create those conditions. So in our test section, we create what it's like for a plane to fly through an icing cloud.
So why did NASA build an icing research tunnel?
As it turns out, during World War II, the Allies lost more aircraft to icing than enemy fighters. They were trying to fly supplies over the Himalayas. So the Air Corps turned to NACA, that's NASA's predecessor, and asked them to build an icing research tunnel so we could understand what was going on and how to fix the problem.
So what do you test in the icing research tunnel, or the IRT?
What we test in the IRT is what makes sense to test. Now if you think about it, if you're in an airplane flying through an icing cloud, what surfaces are most critical to keep ice-free? Well, it's the wings, which provide the lift, get you off the ground, and it's the engine inlet, which provides the forward thrust. So we typically can test just those components, just the wing or the engine inlet.
So what happens when ice forms on an airplane's wing? Well, ice can disrupt the airflow over a wing and will eventually cause the airflow to separate. This separation of airflow creates more drag and less lift. If ice continues to form, the wing will no longer produce the appropriate amount of lift needed to keep the airplane in flight. In some cases, ice creates airflow separation over movable parts, like an aileron. This could create handling or control problems, and the plane could suddenly roll.
As the wing is flying through the air, the ice only accumulates around the leading edge. So that's why ice protection systems only wrap around the front part of the wing. The biggest factor in how the ice grows is temperature. So if it's really cold, the water droplet comes in, hits the front part of the wing, and freezes on impact. And you get this nice pointy rime shape. The more dangerous ice comes during warmer conditions, those closer to freezing, where the water comes in, hits the leading edge, and actually runs back a little bit. If that happens, the next droplet might come in, see that droplet that is frozen, and start to grow. So you might get these ram's horns that grow upstream. Now that significantly disrupts your airflow, and that's way off design, and that's very bad.
Judy, tell me a little bit more about the icing protection system. Do all planes have it?
There's what we call an anti-ice system where you don't allow the ice to grow at all. That's if you got a very hot leading edge. You see that in jets. Then there's a de-icing system which has pneumatic boots, that the boots will wrap around that leading edge, they'll inflate and pop the ice off. So you let the ice grow and then you got to get it off. The pneumatic boots are typically what you see with turboprop aircraft.
Does icing affect planes in, say, a warm climate?
Icing occurs everywhere. You've got to be aware of it. I've got a pilot friend who told me the worst icing he encountered was flying from Florida to the Caribbean in July at 16,000 feet. The worst icing he ever saw. But icing really can occur anywhere and any time. One of the things we do here at NASA is to have better designs. So maybe a system that would automatically turn on the ice protection system if a sensor goes up. The short-term solution is to train the pilots and educate them about how to detect icing, how to be aware of it, train them how to get out of the icing environment if and when they need to. Ideally, icing is a non-issue in the future. We're working to get there.
In 1987, the Icing Research Tunnel was designated an International Historical Mechanical Engineering Landmark for its leading role in making aviation safer for everyone. Coming up, we'll see how a new dental probe designed by NASA will make going to the dentist a little easier. But first, did you know that during World War II, the Allies lost nearly 1,000 planes over the Himalayan mountains due to icing? Flight conditions here were so treacherous that pilots called this dangerous route the hump, or the aluminum trail.